That's really great. So we're going to take questions. This is a unique opportunity. You could ask any one of these panelists any question you might find of interest. Questions? So let me start then. My first question is, Ron, is your training program accredited with ANSI?
Absolutely not. not by choice. We kind of, we try to be as organized in some of the same concepts that they mentioned that ANSI uses. We obviously try and strive for that level, that we are being consistent, that we are continuously, that it actually has value, that we're not just grading people just to sign them off and do things, that we could actually look back and look at a record of training and say, okay, well, they did go through this yearly qualifier. These are the metrics that they were graded on. So we would have a little bit of a leg to stand on, just not as robust as like an ANSI standard.
All right, good. All right, Steve. I know that your content of your training was done with experts, but again, you're not really giving a training program for end users, so it probably doesn't really apply.
We did a bit of that for a while. We did look into accreditation issues and whether or not that was something we wanted to get into, but did not go down that route. So as I mentioned, our simulators are primarily being used for education, some training mainly through local community technical college. Now they have a power plant training program that I assume is accredited to some extent. I mean, they work primarily with one of the major utilities in the region, so I assume there's going to be some need for some standard of, some level of expertise there for the students coming out of that program, but I could not say definitively whether or not there's any accreditation involved in that particular program.
Of course, one of the reasons that I brought Turan in is to get people thinking about this, because a lot of people are not thinking about their training program. When ARC did a number of studies throughout high consequence units, nuclear, fossil, the big reactors in refineries, hydrocrackers, the dangerous exothermic runaway type. We found that some refiners had no training simulators at all. The different types of training, the different requirements of training, the different number of weeks of training was very highly variable. It was much less so in the nuclear industry, where they were bound by a specific standard 3.5. Any other questions? You keep formulating them, keep adding them, because I'm going to ask more questions.
Yeah, Rick, another point. I know when we were developing our simulator, I did research and tried to find all the standards that were out there in terms of simulator development. And as you mentioned, certainly for nuclear simulators, there was information. There were some, it might have been an ANSI specification for simulators that I found, but it was quite an old specification, but we just worked with a vendor in terms of specifications, for the particular simulator that we were looking to develop.
Sure. I just add something. One thing that Steve mentioned with the community college, it is something that we do at the plant as well. We haven't incorporated the simulation into that program as of yet, because it's mostly like a general plant operations program, and it's an associate's degree that they actually get. We do joint training. We allow them to use our plant to teach the various concepts. We have actually added a simulation license and have built a smaller scale simulation system that I put recently in the training building that they are going to try to incorporate into that program, but they haven't built the curriculum yet. It's really new.
All right, great.
And also, just want to mention one thing, that ANSI does not create standards. Public does. Basically, any interested group may get together, a company or association, even sometimes government, and may say, okay, we want to have a standard for this drinking water, and we want to make sure that people don't get sick, or standard for this plastic, that it doesn't include any BPA. So what NC does, it just safeguards the process of how public response can be incorporated during the creation of the standard. Therefore, when there is if there is no NC standard on particular area, it means public did not do their duty, or maybe they were not interested, in that particular area. And when we are, talking in certain industries, let's say nuclear or coal, we say, just do it, because it will actually save many things and ambiguity that you can use an industrial accepted practice. But at the end, NC is just a passive partner here, can help the organizations, when they're helping themselves.
All right, I want to bring Joe McMullen into the conversation. We saw in Ron's simulation that he had I/O simulation. He was getting a little bit more involved in several different aspects of training. So that means he was training maintenance people. He was also, so we also have, of course, to train the console operator. And a lot of times we focus on the console operator. But in the case of the field operator, we also saw that Steve had some very impressive 3D models, and so he's very focused building the right tools. At the time Steve built his simulation, he was using a product called iSim. We know that Schneider Electric has been one of the leaders in 3D with their iSim product and DynSim, and now your most recent combining with Aviva, all right, not to be confused with Arriva, the French company, which some people do. But in any event, Joe, can you give us a comment on the future of 3D modeling and simulation for training operators, console field, and maybe even maintenance?
Sure. So I would say the main value of using immersive training simulators combined with operator training simulation in the control room is the fact that you can have the communication. So you're actually training people on the teamwork that's required from the control room to the field operator, because they're not done in isolation. When you go to work and you go out into the field, you have to communicate with the control room, and that's real life. Being able to practice that communication, be able to practice that teamwork, that's invaluable. And the same goes for sending maintenance personnel out, because you need to go out and you need to talk to the control room to make sure that the lockout, tagout is done correctly and you're in a safe environment, and the lines aren't live or whatever, so that you're safe, to make sure that you have that communication, and practicing that communication, I believe, is one of the key aspects of operator training simulation.
In ARC's market analysis, we find that several suppliers have created, 3D virtual simulations, and they may be only 5% or so of the market share of all simulations. It's interesting that we find that kind of Asian countries who tend to have a more millennial-oriented operational staff, tend to prefer to purchase, are one of the bigger purchasers of 3D virtual simulation. At ARC, we've been wondering, is there just like a threshold before this takes off? We're in a conservative industry. The people that are in charge of operator training in refineries and chemical plants are old guys like me who, are not quite as adept at managing, my iPhone or TV remote. So in any event, can you maybe, Joe, give us some idea of, will immersive training system hit this threshold and suddenly take off?
Sure. So as a vendor, I hope so. It'll be very good for my company. But at the same time, I do. So we've seen companies and interest ramp up dramatically. So it starts with the generic operator training simulator. So instead of necessarily getting and developing a full-fledged high-fidelity simulator for your process unit, what you can do, and what we have seen customers doing now, is doing generic simulators. So while a distillation column at one refinery is different from a distillation column at the other company's refinery, they're similar enough where you can do a generic training simulator and you can get mass amounts of people trained up very quickly. And then as they go out to their site-specific operator training simulator, they can ramp up their operating or their learning speed much quicker. Another technology I think is really starting to click up to help is cloud technology. So investing in an operator training program can be very expensive and very time intensive. The amount of money that you have to spend to bring a trainer off-site or away from their job to train them for how many hours. That can be an enormous investment. What you have now is the ability to use cloud technology where you can log in remotely, so you no longer have those travel days built into your training schedule. And they can be just as effective, especially when you combine it with a generic training model. You can go very quickly through the training process.
Yeah, I think the cloud model works really great for the generic simulators. I know that a lot of other people that build simulators are very concerned about that intellectual property of that simulator. You know, when you expose the exact behavior of your control system, you're opening up the possibilities for those people thinking along the Stuxnet supply, where I can understand that control system and hack into it. So for that reason, actually, a lot of the nuclear simulators are complete isolated network, not connected to the corporate network, in part to maintain that security. But anyway, I have another question is that Steve showed us a lot of digital twin technology where he has a robust physics model. He's also talking about synchronizing that with the statistical data coming from the plant, which basically means reconciling the data to give you the digital twin. You know, it occurs to us that and maybe Ron has a comment on this too, that if you could actually accomplish that and have a digital twin running in synchronization with the running plant, you would be able to then be able to dynamically show the operators of that plant additional information. For example, the composition profile on distillation trays, or the composition and temperature profile, even in 3D, of fixed bed reactors. And so basically that means when they added the reflux to the column, they would be able to look inside the column and watch it cascade down, which they have no sensors for. You know, so the model could tell them more, so they could learn and be better aware, have better situational awareness. Do you see this as one of the future technologies that will come?
So I think as technology improves, and it's improving at a vast rate right now, that will come. And I think that provides you, we call it a digital 360-degree view, but it'll allow you to do a lot more than just training, whether it's enhancing your reliability by doing predictive or proactive maintenance, or setting out and making sure that you're enhancing safety, making sure that there's all sorts of things you can do to maintain your plant, to make sure it's operated safely when you have that view. So I think that technology is coming, and when it does, it's going to change the way we run our plants.
I definitely see that coming. I mean, when we develop the dynamic simulators now, usually you're doing some dynamic model validation. So you will validate your simulator based on certain operating points in existing plants, perhaps if you're building a simulator for an existing plant. And that simulator provides you with a wealth of information on variables throughout the plant, like for a column, for example, that you may not have measurements being displayed to operators. So if you did have a live dynamic simulator running, it would provide a lot of additional information to operators. And when we develop these dynamic models, there are some parameters that are sort of tuned to match a given plant's operation. So if you connected up one of our simulators to an actual plant and we're updating parameters in real time to keep that dynamic simulator in tune with the plant, yes, operators would have access to all variables throughout the plant, even variables that aren't being measured. So I think that would be extremely valuable, and that's essentially what's being done with the data-driven digital twins that we heard discussed throughout the week. I don't know if anybody has a high fidelity for sort of first principle simulator running right alongside a plant, in some way taking plant data to make some parameter updates in real time to keep that model tuned to the plant.
And I think that's just it. It's not happening in real time, because I've spent a lot of my time over the years we build these models based on all the engineering data we have. We have P&IDs, we have equipment data manuals, we have everything that comes from the various vendors, and we piece these systems together one model at a time, so each pump and each motor. Sometimes we have operational data to tune to from the beginning if it's existing equipment. But I know for us at the plant that I was talking about at Coronado, we've had a multitude of changes over the last 6 years where we've added emissions equipment, we've added SCRs, which change our operating profiles. So we had to add new types of systems just to make that work so that we could increase how much we could ramp load. What is our minimum now? What is our maximum? So as we go through those things, we build these models out of nothing, and then we go back and look at the data when we really run it and see, well, how close did we get? Well, so then looking at it that way, anytime anything fails at the plant, I spend a lot of time replicating that on the model, whether it's to teach operators, don't do that again, or to find ways that we can improve our operations. So right now that's done manually. It would be excellent to do it automatically, but then that also opens you up, as you mentioned, the cybersecurity implications of connecting a simulation system that is a detailed model of not only your process but also your control system. Do you connect it that way? There are technologies to allow that to happen, and I think they're coming. Right now, though, it doesn't happen automatically. It's happening manually from people like me that just are fascinated by it and want to make it better.
Well, then I certainly am aware that several refineries operate real-time optimization, and they certainly do have physics-based models that are synchronized in data reconciliation. All the major companies out here, Schneider Electric included, Honeywell, Yokogawa, all have the capability of having live dynamic models running that plant. And they're necessary to do that, to optimize. And they can even handle dynamics and say, well, what if I, went through this sequence of events, what would happen? And so they can kind of jump off of those and handle those what if,
That's true.
Yeah, I think sort of the mode of operation you're discussing is tended to be steady state simulation. So you get the plant data from the controllers, do your data cleaning, do your parameter estimation to match the live plant data with your model, solve some real-time optimization, and then send the new set points to the plant, wait for a steady state. But I think there are some, you want to try to do that faster and faster. Typically, when it first started off in oil and gas, it might have been once a shift they'd run the real-time operator, but the more often you can run that, the closer you can keep your plant running against constraints, where there's probably your highest profitability.
Yes.
Yeah.
The constraint pushers are
Right.
missing in many cases.
Right.
And I would add, I think that goes back to the increasing technology as it continues to advance, and the enhancement of the digital twin. You're going to be able to go from your traditional design to operator training to optimization, all within a single product, all within a single platform or solution, and be able to share that data throughout that life cycle. And I think that's going to be a key to being profitable in the future.
I think the key is keeping the real-time performance. If you have a lot of transients going on in your plant, your model may not be running in real time. So you have to have everything in place to properly deal with that if you're running an actual dynamic optimization model alongside a plant.
Right. Steady state's hard enough to get accurate, especially when you have to move from this steady state to a second steady state. But then to get the dynamics, that's especially hard. I also wanted to make one other comment, which I mentioned. Ron in his presentation pointed out that they found 200 errors in their control system configuration as a result of training operators. And that's definitely been my experience. In fact, as a former DCS engineer that's been at many factory acceptance tests, I have found that the most effective factory acceptance tests are those that are done with a simulator connected to the control system before you ship that control system out to a new greenfield facility. So the best way to test control systems is with a dynamic simulators, and the operators will find unique and creative ways to break and challenge the control strategies that you thought were so perfect, but weren't.
Yeah, as soon as you feel comfortable or you think that you've covered every possible control or operational scenario, or any button that somebody could push to possibly make a mistake. All you have to do is turn an operator loose on it, because I came from an operations background. We will find a way to break it. There's no.
So any other questions for our audience? I hope you enjoyed this. These, by the way, we do encourage you to rate on your phone the presentation, and keep in mind, in a few months, these presentations might be of use and available as recordings, so maybe you would be able to share them with others in your organization. Thank you very much for your attendance.